In this video, we are going to finish up talking about symmetry. We already talked about point symmetry, and we talked about symmetry to the origin, which we'll revisit. But today we're going to talk about line symmetry and symmetry with respect to the x-axis, the y-axis. Y is equal to x and y is equal to negative x. Again, we'll revisit symmetry to the origin when we discuss all of the algebraic tests. So I'm not a big fan of memorizing, we'll show you how to figure out the algebraic tests, but let's first talk about line symmetry. So let's say you have a point P and an image point P prime. It's going to be symmetric to the line L if and only if L is the perpendicular bisector of P and P prime. So if you look at P and P prime here, if they're connected into a line segment, L would have to intersect it perpendicularly and bisect the segment in order for P and P prime to be symmetric to line L. So keeping that in mind, let's look at the tests. We're going to derive the tests here. So if we look at a point, let's call this 3, 2, or point AB. If we have, we've reflected across that x-axis, this point would then be 3, negative 2. And the x-axis would be the perpendicular bisector of that segment. So the algebraic test for something that is symmetric with respect to the x-axis, you're going to contain both the point AB as well as the point A, negative B. We can do something similar to a point that's symmetric to the y-axis. Let's call this point 1, 3, or again, that's point AB. If it is symmetric with respect to the y-axis, the relation would also have to include the point negative 1, positive 3. Deriving the test, that would be negative A, positive B. So if it's symmetric with respect to the y-axis, the relation has to contain AB as well as negative AB. Y equals x is the line through the origin, has a slope of 1. It's the diagonal. It goes through quadrant 1 and quadrant 3. So if we take a point here, again, let's call this 1, 3. In order to be symmetric with respect to y equals x, you're also going to have the point 3, 1. So if we have AB, we would also need to have BA. So the test, you're going to plug it in and verify that both AB and BA are in your relation. We can also have symmetry to the y equals negative x line. Similar to y equals x, this is a direct variation. It goes through 0, 0. It's going to be contained in quadrant 2 and quadrant 4. If we look at a point here, let's call this point, let's start again with 3, 1. For this to be the perpendicular bisector, for this L to be the perpendicular bisector of these 2 points, this point is going to be at negative 1, negative 3. So we would have the point AB as well as the point negative B, negative A. So if we complete this chart, If it's symmetric to the x-axis, remember that's here, we've got this point and this point, you can see that it'll contain AB. It also needs to contain a negative B. If it's symmetric to the y-axis, again, you've got the points here, you're going to have AB and negative AB. If it's symmetric to y equals x, you have these 2 points. This is going to give me AB and BA. If it's symmetric to the negative x-axis, sorry, a little crooked there, you'll have the point, let's say -1, +3. It should be -3, +1. So that's negative B, negative A. Now again, thinking about something that's symmetric to the origin, typically we show this with like a cubic, can be any others. So 1, 1 will return a negative A, negative B if it's symmetric to the origin. In the next video, we'll look at using these tests and so that we can verify what type of symmetry, if any, a relation or a function has.